5.6, we are going to learn another way or another form of writing a linear equation. Most linear equations in this chapter are written in slope-intercept form. We write in slope-intercept form when we want to graph a linear equation. In 5.5, you learned how to use point-slope form. 5.6 will show you standard or general form, and that is simply ax plus by equals c. In this form, notice that the variable terms are on the left side of the equation and the constant term is on the right. So a coefficient to x, a coefficient to y, and then the constant term on the constant term is on the right side of the equal sign. So in example 1, we are given an equation in slope-intercept form, and we're asked to write it into standard form with integer coefficients. So we cannot have a fraction coefficient. So to write the equation in standard form, we'll need to isolate the variable terms on the left and the constant term on the right. So we're going to go ahead and we'll need to move the 2/5 x to the left side of the equation. So we have y equals 2/5 x minus 3. We want to make sure that we can get rid of the fraction. So to get rid of the fraction, I'm going to go ahead and I'm going to multiply both sides by 5. That will give my left side 5y, and then when I distribute the 5 to both of the terms on the right side, I will get 2x minus 15. Now I can go ahead and make sure that my variables with their coefficients are on the left side. So I need to move my 2x. And to do that, I need to subtract it from both sides. And then I always write my x term first. So I'm going to write negative 2x. I have a positive 5y. And that's going to equal a negative 15. And now I have all integer coefficients, and I have my variable terms on the left, and I have my constant term on the right. Now, this is one of those places where the book sometimes contradicts itself. It says a linear equation can have more than one standard form. For instance, if you multiply each side of the standard form by a negative 1, then you would get 2x minus a positive 2x, and then a negative 5y equals a positive 15. This is also in standard form. Both ways are correct. In example 2, we're going to write the standard form of an equation of the line, and we have a point that is passing through, and we have a slope. So you get to go ahead and use what you did in the lesson that you practiced today and use your point slope form. So first of all, there's the formula for point slope again. Not sure why I'm getting those dotted lines. And so I'm going to go ahead and I'm going to substitute in the values that are highlighted in red. So I'm going to have y minus, I'm going to rewrite that y. Okay, y minus, and then my y term would be in my coordinate point, and that would be 3 equals, now I'm going to use the slope that they gave me, negative 2, and negative 2 is going to be distributed to the to x minus, and then the coordinate point I have there, which is a negative 4, so a negative minus a negative would give me positive, so I'm going to go ahead and change that right away. So now I'm going to distribute. Left side stays the same. I get negative 2x minus 8 on the right-hand side. And to put in standard form, I want to get my coefficients on, or my variables with their coefficients on one side, the left side, and I want to get my constant terms on the right. So I'll move my variable first. I would recommend doing this in 2 steps. Sometimes when you put it in 1 step, you guys make your most mistakes. I'll write my x first. I have 2x. I have a positive y and negative 3 equaling negative 8. I need to move my constant term. So I'm going to add 3 to both sides. I'm going to have to just write to the side here. Now I have 2x plus y. There are my variables on the left side. And I'm going to have on the right equals the negative 8 plus 3 would give me negative 5. So now that equation is in standard form. Example 3 is going to talk about special lines, our horizontal and our vertical lines. So to write those in standard form, we've talked about this before, and just to tell you again, for a horizontal line, because it has a point on the y, our horizontal one here, I'll change to blue, our horizontal line is blue, because the, sorry, I lost my train of thought, because the horizontal line has a point with a y coordinate of 3, then the standard form for that equation would simply be y equals 3. There would be no x term, so our variable is still on the left and our constant term is on the right. So then you can imagine for the vertical line, because there is no y coordinate and the vertical line is crossing the x-axis at negative 3, our standard form equation would be that x equals negative 3. Again, variables on the left, constant on the right. It's just that in both of these special cases, we only have one variable. And then we have a quick, you can pause this if you need to. Make sure you have these in your notes. It's just a concept summary of all the different types of equations of a line. And we'll finish up with a real life situation. We're at a barbecue and you are in charge of buying the hamburger and the boned chicken for our barbecue. The hamburger costs $2 per pound and the boned chicken is $3 per pound. And you have $30 to spend. So if you're going to write an equation that models the different amounts of hamburgers and chicken, because we have 2 different variables there, variable for hamburgers and the variable for chicken, that you can buy, and you have your constant term of the $30. So we would go ahead and start out filling in just our equation before we change it into standard form. So we would have $2. Oh my goodness, that was bad. Let me try that again. Okay, we would have $2 for the pounds of hamburger. We don't know how many pounds yet we would have. We're going to add that to the $3 per pound of chicken. It's a different variable. And we know that we have the $30 to spend. So that would equal 30. Now we could go ahead and we could try different we could do an algebraic model or a table of all the different situations we would have there, substituting in our x to find our y. And so if we bought no hamburger at all, then we could buy 10 pounds of chicken. And if we went ahead and we could say we bought, let's just say 3 pounds of the hamburger, so 2 times 3 is 6. So then we could only buy, well, not only, but we could buy 8 pounds of chicken. And then it would go, we could do this so on and so on. We'll just go ahead and we'll do 0. This time I'm not going to buy any chicken. Then how much hamburger could I buy? And that would be 2 times what would equal 30, and that would be 15 pounds of hamburger. So that's modeling a real life situation of standard form. 2 different variables. We wrote both those variables on the left-hand side, kept our constant term, our cost on the right-hand side of the equal sign. And that will conclude standard form for 5.6.